Students, in today's class we will learn how to integrate integral 0 to pi over 2 dx divided by 4 times sine squared x positive cos squared x. So foremost what I'm going to be doing is I would be dividing the numerator and the denominator by cos squared x. Now when I do that, I would get integral dx divided by cos squared x divided by 4 times sine squared x divided by cos squared x positive 5 times cos squared x divided by cos squared x. Now clearly the cos squared x that you see in the denominator can be cancelled, giving me integral. Of course the limits are 0 to pi over 2. Now 1 over cos squared x. Now 1 divided by cos squared x is nothing but secant squared x. Okay. Now because of that trigonometric formula we know, I can replace this as secant squared x times dx divided by, now sine squared x divided by cos squared x is nothing but tan squared x. This is the next trigonometric formula that we have to know. So because of that, this is going to be 4 times tan squared x positive 5. Now the limits are 0 to pi over 2. Now what I'm going to do is I am going to be using the substitution. Let tan x be equal to some u. Differentiating both sides, we get so what happens when you differentiate tan x? Differential of tan x would give me secant squared x dx. Differential of u would give me du. Now the limits will also change. So what does that mean? Now we got the first limit. So when x is equal to 0, I've got u is equal to tan of 0, which would be 0. So this is the first limit. The next one, when x is equal to pi divided by 2, what happens to u? U is going to be equal to tan pi divided by 2. So that is going to be nothing but sine pi over 2 divided by cos pi over 2. Sine pi over 2 is 1, cos pi over 2 is 0. So that means we have a limit as infinity. So this is the second value for the limits. So what happens now? So therefore integral 0 to pi over 2 will now be rewritten. So it's actually secant squared x dx divided by 4 times tan squared x positive 5. I'm going to be rewriting this as integral 0 to infinity. In the place of secant squared x dx, I would be placing du. In the place of tan x is going to be u squared and retain 5 as it is. Now what I'm going to do is I'm going to be taking 4 out. So that would mean I would now have 1 divided by 4. The limits are 0 to infinity. Du divided by u squared positive 5 divided by 4. I can rewrite this further as 1 over 4 limits 0 to infinity du divided by u squared positive root of 5 divided by 2 squared. Okay. Now this is similar to the formula. So what is the formula we studied? We know that integral b to infinity dx divided by a squared positive x squared is equal to 1 over a times pi over 2 negative tan inverse of b divided by a. This is a formula which we started off by learning. So now because of this formula I can now rewrite this. So this is going to be equal to 1 over 4. In the place of a I have got 1 root 5 over 2. So this is going to be 1 divided by a root 5 divided by 2 times I can open a parenthesis, pi over 2 negative tan inverse of, in the place of b you got 0, so it's going to be 0 divided by a. Now tan inverse of 0 will get cancelled, so that would mean I would now have 1 over 4. If you flip this, it's going to be 2 divided by root 5. I also have a pi divided by 2. Now clearly what happens, the 2 that you see in the numerator can be cancelled with the denominator, giving me pi times 4 root 5. So the solution set, so this implies integral 0 to pi over 2 dx divided by 4 times sine squared x positive 5 times cos squared x is equal to pi over 4 times root 5. So that is the final answer to the question.